All right, guys, welcome back to part 3 of the video. We continue with our revision. So we've got to question number 10. A company is building an e-commerce web application on AWS. The application sends information about new orders to an Amazon API gateway REST API to process. The company wants to ensure that orders are processed in the order that they are received. Which solution will meet these requirements? Which solution will meet these requirements? A, use an API gateway integration to publish a message to an Amazon simple notification service, as Amazon SNS topic, when the application receives an order. Subscribe an AWS Lambda function to the topic to perform processing. B, use an API gateway integration to send a message to an Amazon simple queue service, that is Amazon SQS, FIFO, first in, first out queue when the application receives an order. Configure the SQS FIFO queue to invoke an AWS Lambda function for processing. C, use an API gateway authorizer to block any requests while the application processes an order. D, use an API gateway integration to send a message to an Amazon simple queue service, that is Amazon SQS standard queue, when the application receives an order. Then configure the SQS standard queue to invoke an AWS Lambda function for processing. Right, so let's spend some time with this question and try to see those which qualify to be the answer. In most cases, you'll get two of the options which will be competing. Two of them will be competing for the answer, and the other two will just be a distraction. Okay, so if you're able to get rid of the distraction, then it helps you to focus on the answer. I believe the distraction in this is C, because it's just talking about API gateway authorizer to block any request while the application processes an order. The question is that really the requirement? Company is building an e-commerce web application. The application sends information about new orders to an Amazon API gateway REST API to process. And what the company wants is to ensure that orders are processed in the order that they are received. So that is very, very critical. So it's not just blocking any request while the application processes an order. They want the order to be processed in the order that they are received. That is first in, first out. So C does not take care of that, And if you look at D says use an API gateway integration to send a message to an Amazon simple queue service, that is SQS standard queue, when the application receives an order. Then configure the SQS standard queue to invoke an AWS Lambda function for processing. Okay, so if you are configuring SQS standard queue to invoke an AWS Lambda function for processing, okay, let's just copy this and ask. Let's just put it in ChatGPT and let's see what it will tell us. Okay, without even asking anything. So I'm going to make it configuring SQS standard queue. What happens? I'm just going to say what happens. So it says when you configure an Amazon simple queue service standard queue to invoke an AWS Lambda function for processing, the following sequence of events occurs. So we've got message in SQS queue. First, messages are sent and stored in the SQS standard queue. The Lambda trigger configuration. You configure the SQS queue as an event source for your AWS Lambda function. This means you specify the SQS queue as a trigger for the Lambda function. When configuring the trigger, you define the batch size, which determines the number of messages that Lambda will retrieve from the queue in a single batch for processing. Okay, so yes, Lambda can retrieve application from a queue for processing. But again, the question is, does it take care of the first in, first out process? That is a major requirement. It could help, but it might not be able to do that. And you look at A and B, you can see here, especially for B, it says use an API gateway integration to send a message to an Amazon simple queue service, FIFO queue, when the application receives an order. Then configure the SQS FIFO queue to invoke an AWS Lambda function. So you can see for B that the FIFO, the Amazon simple queue service, okay, is used to invoke the AWS Lambda function for the processing. So it means that the Lambda function for the processing will meet the requirement of first in, first out. Okay, so that is why B is competing as an answer. But if you look at A, it says use an API gateway integration to publish a message to an Amazon simple notification service. When the application receives an order, then subscribe an AWS Lambda function to the topic to perform processing. Okay, so if you use an API gateway integration to publish a message to an Amazon simple notification service topic, what message is it publishing to the SNet? Is it telling it if the message is that it should, process the application in the order in which it receives it, then you can see that also can be as a possible answer. Okay, but because we are not really sure if that is configured into the Amazon simple notification service, we can't tell that is an answer. Okay, I'm just trying to find out from those who chose A as an answer if anybody has got a reason for choosing A. But if you look at the community, you can really see that almost everybody chose B. But if you review the solution, it will surprise you to see that it says the answer is A. Okay, now let's put the same question. Let's put the same question here in ChatGPT, and let's see what ChatGPT will say. Okay, let me copy the options because it might be able to give me an explanation of why it says that. ChatGPT, as we know, is not always reliable. So it's good to use ChatGPT when you already understand what you are asking. So it's like you understand something already, and you want to ask somebody's opinion about it. If you don't understand anything about it, whatever the person will tell you, whether it's even rubbish, you will take it hook, line, and sinker. But if you look at ChatGPT, that is how you're supposed to use it. You only query ChatGPT on something you already understand, and basically it is just giving you an opinion or helping you to see it in a particular way. So we understand the whole thing, but we want to see what ChatGPT will say, and also if it will agree with the fact that the answer is A. Okay, so let's see. Now, ChatGPT also says the correct solution for ensuring that orders are processed in the order they are received is option B. Because if you use an API gateway integration to send a message to an Amazon simple queue service, when the application receives another, so here's why. It says first, FIFO queue, Amazon SQS FIFO first in first out queues are designed to preserve the order in which messages are sent and received. When you send messages to an SQS FIFO queue, they are processed in the exact order they are received. This ensures that orders are processed in the order they are received by the API gateway. And the Lambda integration, by configuring the SQS FIFO queue to invoke an AWS Lambda function, you can process the orders asynchronously in a scalable manner. So Lambda can handle the processing logic without the API gateway having to wait for the processing to complete. This decoupling ensures that the API gateway remains responsive to incoming requests, enhancing the application's overall performance and responsiveness. Now, it says option A, that is using Amazon SNS, and option D, using SQS standard queue, do not guarantee straight ordering of messages. While SQS standard queues provide a high throughput, they don't guarantee the order of messages. SNS, being a pub subsystem, also doesn't guarantee message ordering among subscribers. And option C, it says using an API gateway authorizer to block requests does not address the requirement of processing orders in the order they are received. It simply blocks requests, which is not a scalable or efficient solution for processing orders in a timely manner. Yeah, so even ChatGPT agrees that the answer is B. So I'm surprised that, it says that the answer is A. So it is up to you to tell me if you agree that the answer is A or B. Put it in a comment. Tell me what you think in the comment. Right, so question 11. A company has an application that runs on Amazon EC2 instances and uses an Amazon Aurora database. Amazon Aurora database. So maybe it's worthwhile revising what Amazon Aurora database is. Amazon Aurora database. Just give me something brief. So Amazon Aurora is a relational database service provided by AWS. It is compatible with MySQL and PostgreSQL, offering high performance, scalability, and availability for database workloads. Okay, so it is a relational database service provided by AWS, a relational database. Now we've got one which is not relational, and that is DynamoDB. Okay, yes, but Aurora is relational and is compatible with MySQL and PostgreSQL. Okay, good. That's all I need. So a company has an application that runs on Amazon EC2 instance and uses that means the company has got a relational database. The EC2 instances connect to the database by using names and passwords that are stored locally in a file. The company wants to minimize the operational overhead of credential management. What should the solution architect do to accomplish this goal? Okay, so which of these can help the company minimize operational overhead of credential management? So A, use AWS Secrets Manager, turn on automatic rotation. B, use AWS Systems Manager parameter store, turn on automatic rotation. C, create an Amazon S3 bucket to store objects that are encrypted with an AWS key management service, AWS KMS encryption key. Migrate the credential file to the S3 bucket, then point the application to the S3 bucket. Then D, create an encrypted Amazon Elastic Block Store, Amazon EBS volume for each EC2 instance. Attach the new EBS volume to each EC2 instance, then migrate the credential file to the new EBS volume. Point the application to the new EBS volume. Okay, so what is going to be the answer? Give you some few seconds to think through. Okay, so the major thing the company wants is to minimize the operational overhead of credential management. So I believe that if you want to minimize the operational overhead of credential management, you should automate the credential management. You should automate the rotation of the credential management. Sorry, you should automate the rotation of the credentials. Changing passwords to be automated. So that alone should rule out C and D, even if it can help. Okay, we want a system that will automate the whole, process of credential rotation. Good. So I think C and D are just distractors. Okay, but maybe for the purpose of learning, we can quickly look at what AWS Key Management Service does. Yeah, just to remind ourselves of what it does. So it says here that AWS Key Management is a managed encryption service that allows you to create and control the encryption keys used to encrypt your data. When you use AWS KMS, you are the ultimate custodian of your data. AWS KMS helps you manage the encryption keys used to protect your data. Okay, so it's like an encryption. It's just like Google Password Manager. So this KMS, key management system, is like a password manager that you use to manage your thing. So there will be some involvement in it, I believe. So, and we are not even talking about encryption management here. We are talking about credential management, which is just simply setting up an automated system where, your password will be changed, let's say every 30 days. Yeah. So, because you want to minimize the operational overhead of the credential management. Yeah. And the Amazon Elastic Block Store volume for each, that is going to give you a lot of work to do. But maybe we want to revise what Amazon Elastic Block Store volume is. So it says Amazon Elastic Block Store provides persistent block storage volumes for use with Amazon EC2 instances in the AWS cloud. Here are the keys. So it provides persistent block storage. So it's got nothing to do with the credential management that we want. Yeah, so C and D are out. Down, the focus will be on A and B. Okay, so either we use AWS Secrets Manager or we use AWS Systems Manager Parameter Store. Now, which of the two will be best for credential management that minimizes operational overhead? So I'm going to query ChatGTP and say, I believe that it should be B, the Systems Manager Parameter Store. Okay, so let's just query ChatGTP and say, which of these two, so which of these two is best for credential management that minimizes operational overhead? Okay, we've got AWS Secrets Manager and AWS Systems Manager Parameter Store. So AWS Secrets Manager or AWS let me just copy it and make it quick. Yeah, so it says both AWS Secrets Manager and AWS System Manager are capable service for credential management, each with its own advantage. The choice between them depends on your specific requirements and preferences. Let's compare the two. Okay, just tell me. So if automation integration with specific AWS services are critical for your use case and you're willing to invest in these features, AWS could be the best choice. Potentially higher cost. If you prioritize cost effectiveness and simplicity, yeah. So this is what I want: AWS System Manager Parameter Store, because I want to minimize operational overhead. Yeah. So the Secret Manager does the same thing, but it doesn't minimize operational overhead. So the answer should be B. A lot of people chose Secrets Manager, but I believe the answer is B, even based on what ChatGPT has told us. Okay, good. So let's move to question number 12. A global company hosts its web application on Amazon EC2 instances behind an application load balancer, ALB. The web application has static data and dynamic data. The company stores its static data in an Amazon S3 bucket. The company wants to improve performance and reduce latency for the static data and dynamic data. The company is using its own domain name registered with Amazon Route 53. What should a solutions architect do to meet these requirements? A. Create an Amazon CloudFront distribution that has the S3 bucket and the ALB as origins. Configure Route 53 to route traffic to the CloudFront distribution. B. Create an Amazon CloudFront distribution that has the ALB as an origin. Create an AWS Global Accelerator Standard Accelerator that has the S3 bucket as an endpoint. Configure Route 53 to route traffic to the CloudFront distribution. C. Create an Amazon CloudFront distribution that has the S3 bucket as an origin. Create an AWS Global Accelerator Standard Accelerator that has the ALB and the CloudFront distribution as endpoints. Create a custom domain name that points to the accelerator DNS name. Then use the custom domain name as an endpoint for the web application. And D. Create an Amazon CloudFront distribution that has the ALB as an origin. Create an AWS Global Accelerator Standard Accelerator that has the S3 bucket as an endpoint. Create two domain names. Point one domain name to the CloudFront DNS name for dynamic content. Point the other domain name to the accelerator DNS name for the static content. Use the domain names at endpoints for the web application. Okay, so let's have a think about this. You can see that the options are quite loaded because of the requirements, but don't be deceived. Sometimes the loaded options are not even the answer. It could be the answer, but sometimes they just load it to distract you. So just understand the requirements and that will help. So let's have a think about it. Right, so question 12. Now, if you look at the options for question 12, you can see that the first part is CloudFront distribution. Create an Amazon CloudFront distribution. Create an Amazon CloudFront distribution. C is create an Amazon CloudFront distribution. D, create an Amazon CloudFront distribution. So it tells you that CloudFront distribution is critical to meet the requirements, that the solution architect needs to build. Okay, because if you look at CloudFront distribution, is a content delivery network CDN service provided by Amazon Web Services. It delivers content, including web pages, videos, images, and other assets to users based on their geographical location, ensuring low latency and high transfer speeds. When you create a CloudFront distribution, here are the key aspects to consider. Yeah, so, content delivery network, okay, delivering all sort of content and to people based on all geographical location. And the key thing is that it ensures low latency and high transfer, and it's one of the requirements that solution architect has to meet. The company wants to improve performance and reduce latency. That is why you've got to create an Amazon CloudFront distribution. Okay, so that is, something that is accepted. So you can see that A, B, C, D, they've all got that in it. Okay, now moving forward, there is another requirement also, that the fact that the web application has static data and dynamic data, and the fact that the company is using its own domain name registered, the own domain name registered with Amazon Route 53. Okay, now because of that, it, I believe, will limit the answer to A and C. Okay, so A says create an Amazon CloudFront distribution that has S3 bucket and the ALB as origins. Then configure Route 53 to route traffic. Yeah, so here configuring Route 53 in a way is meeting the requirement, for the Route 53. And if you look at C, it also says after creating the CloudFront distribution that has S3 bucket as an origin. Now, if you look at A, it says S3 bucket and ALB as origins, but for C, it's only S3 bucket that is as an origin, which is a key difference between the options. Now, create an AWS Global Accelerator Standard Accelerator that has ALB and the CloudFront distribution as endpoints. So, in option C, ALB and Global Accelerator Standard Accelerator are endpoints. They are not, the ALB, okay, the application load balancer is not an origin. It serves as an endpoint, okay, which is very, very important. Now, if you come here, ChatGTP says the answer is C, which I believe is true. Okay, now, even though the community voted A, the answer is C. About 77% of people chose A, which is not surprising because it looks like the answer. But to say that configure S3 and ALB as an origin, ALB as an origin is maybe where the problem is. So ChatGTP says the answer is C. Now here's the reason. Okay, Amazon CloudFront for static data. By creating a CloudFront distribution with the S3 bucket as origin, static data stored in S3 can be cached at the CloudFront edge locations globally. This ensures low latency and high performance for static content delivery to users. Then the next thing is the AWS Global Accelerator for dynamic data. AWS Global Accelerator can be used to route dynamic content. Okay, so the CloudFront will help with the static content by caching it at the CloudFront edge location. And the Global Accelerator for dynamic data will help with the dynamic data. Okay, so it's going to route the dynamic content, and the Global Accelerator uses the AWS Global Network to optimize the path from the user to the application. It allows you to leverage the AWS Global Network infrastructure to improve availability and performance for user traffic. And the mention of the custom domain name that was created by Route 53, which kind of configured that creating a custom domain name that points to the Global Accelerator DNS name ensures that users access the application via a user-friendly domain while benefiting from the optimized routing provided by Global Accelerator. So this setup optimizes performance and reduces latency for both static and dynamic data, allowing users to access the web application efficiently from anywhere in the world. So the answer is C because it contains a provision, it contains an AWS that will help with both static and dynamic data. And it also meets the custom domain name requirement. Okay, so that is why we've got the best answer, 2BC. Perfect. We will end here, and in the next video, we are going to go on with question number 13. See ya. Bye for now.